time complexity is analyzed for very large input size and worst case scenarios. Now, let's take an example and try to calculate its time complexity. So, we have Tn, which is equal to 2n square plus 3n plus 1. The first step is to drop the lower order terms, that are 3n plus 1 in this case. Next, we drop the constant, that is 2. So, we get the time complexity as big O of n square for this particular polynomial. Now, let's look at some rules for finding out the time complexity in algorithms. First, let us look at how do we calculate the time complexity of a single loop. So, this is our for loop which runs from 1 to n. And we have this expression inside the for loop x equal to y plus z, which takes constant time to execute. Now, the time complexity will be n times time taken for this expression, which is a constant, let's say c. So, the time complexity will come out to be c times n. And in big O terms, we can neglect this constant and simply write the time complexity as big O of n. Now, let's look at nested loops. As you can see, we have two loops which are nested. Let's try to find out the time complexity. So, this is the expression which takes constant time to execute. Now, we simply multiply the time complexity of each loop. So, this is the outer loop which will run n times. And for each run of the outer loop, this inner loop will also run n times. So, the total running time will be some constant time multiplied by n into n, which is equal to n square. So, we can say that the time complexity is big O of n square. Next are the sequential statements. Let's say that we have an expression which takes constant time to run. Let me denote it by C1. After that, we have this for loop which we have seen before, and it will take C2 times n time to run. Then we have another for loop which takes C3 into n time to run. So when we have sequential statements like these, we simply add the time taken for each statement. So let me do that. In big O terms, we can ignore these constants C1, C2 and C3, and we have the time complexity as big O of n. Next, let us look at how do we find out time complexity when we have conditional statements such as if-else. We evaluate the situation when values in if-else conditions cause maximum number of statements to be executed. So let's say that inside this if condition we have a for loop whose time complexity is big O of n. And inside this else condition we have a nested for loop whose time complexity is big O of n square. So we consider the else condition as it has a greater time complexity, and hence the overall time complexity will come out to be big O of n square. Now let's look at the comparison of time complexities. So we have big O of 1, which is the smallest and the best. Then we have big O of log n. Then comes big O of n. Then it is big O of n log n. Then we have exponential time complexities. And finally, we have big O of n factorial, which is the worst. This is a chart of time complexity of various sorting algorithms. It is highly recommended to learn them by heart as it comes very handy. Alright, so till now we have only talked about time complexity of a program. However, there is another factor which affects the execution of a program, which is space. Space complexity of an algorithm quantifies the amount of space or memory taken by an algorithm to run as a function of the length of input. Let's quickly understand it with an example. Assuming that an integer takes 4 bytes of storage in memory, and in this piece of code we have 4 integers a, b, c and z. So the total space will come out to be 4 into 4 plus 4. This additional 4 is for the return statement. Hence, this comes out to be 20 bytes. So this is a constant space running algorithm. There is usually a trade-off between optimal memory use and runtime performance. In general, for an algorithm, space efficiency and time efficiency reach at opposite ends, and each point in between them has a certain time and space efficiency. So, the more time efficiency you have, the less space efficiency you have, and vice versa. For example, merge sort is exceedingly fast but requires a lot of space to do the operations. On the other hand, the bubble sort algorithm is exceedingly slow, but it requires the minimum space. So, by now, you should be easily able to calculate the time or space complexity of a program. That's all for this video. Thank you for watching.